In 1960, 11,000 meters deep, the hull of the bathyscaphe Trieste groaned, a sound of doom. Jacques Piccard and Don Walsh peered through the small quartz window, and then they saw something stir outside. The Mariana Trench is a scar on Earth's crust, a deep gash at the bottom of the western Pacific Ocean. Stretching over 2,500 kilometers, it's home to the lowest known point on our planet, the Challenger Deep. 11,000 meters of dark, icy water separate the surface from that abyssal seafloor. To give you an idea, if Mount Everest were placed inside the trench, its summit would still be over 2 kilometers beneath the surface. The pressure down there is crushing, 1,100 times greater than at the surface. It's the equivalent of having 50 jumbo jets stacked on your body. Metal deforms, air compresses until it becomes liquid. Life, as we know it, shouldn't be possible. Yet human curiosity is as relentless as the abyss's pressure. Since the pioneering expedition of HMS Challenger in 1875, which first measured its colossal depth, we've tried to unravel its secrets. We've sent probes, robots, and on rare, courageous occasions, humans in vehicles designed to withstand hell itself. Each dive is a journey to another world, a world without sun, governed by physical laws that seem warped, a world of absolute silence, broken only by the hum of equipment and the sound of our own heart, beating against the certainty that the slightest flaw, the smallest crack, would mean an instant end. Abyssal Plume. Today we plunge 11,000 meters into the Mariana Trench to uncover what truly lies at Earth's deepest point. The descent begins. The submersible, a sphere of polished titanium, slips beneath the Pacific's blue surface. The first 100 meters are teeming with light and life. At 200 meters, sunlight begins to surrender to the deep blue. 500 meters, color fades, replaced by a perpetual twilight. We're entering the mesopelagic zone, the realm of the gloaming. At 1,000 meters, the darkness is total, absolute. Sunlight is no more. The only illumination comes from our vehicle's headlights, slicing through the black water like blades. The external temperature plummets to near 4 degrees Celsius. The pressure is already 100 times that of the surface. We are officially in the bathyal zone, the midnight zone. The submersible continues its descent. 2,000 meters, 3,000, 4,000. We cross the threshold into the abyssal zone. Its name comes from the Greek abyssos, meaning bottomless. For a long time, science believed life was impossible here. The pressure is 400 times that of the surface. Darkness is eternal. The cold is constant. But the journey isn't over yet. Below 6,000 meters, we enter the Hadal zone. The name is a reference to Hades, the underworld of Greek mythology. It's a designation reserved only for the world's deepest trenches. Fewer people have visited the Hadal zone than have walked on the moon. Our instruments measure the pressure increasing with every second. 7,000 meters, 8,000. The titanium hull groans under the weight of an entire ocean. The silence within the cabin is tense, broken only by the calm voice of mission control and the beeps of the sensors. Outside, the water is no longer just water. It has become a solid force, an invisible press trying to crush us out of existence. At 10,000 meters, we are more isolated from humanity than astronauts on the International Space Station. 11,000 meters, we touch down. The seafloor of the Challenger Deep isn't an empty desert, it's a world. Our headlights reveal a landscape of fine sediment, almost like dust, accumulated over millennia. And here, in this hellish environment, life surprises us.
The first things we see are xenophyrophores, single-celled organisms, yet gigantic, some the size of a human fist. They construct complex shells from minerals and sediments on the seafloor, creating structures that resemble delicate alien architectures. They shouldn't exist, but they do. Further on, something stirs. It's an amphropod, a type of crustacean, but here, in the Hadal Zone, abyssal giantism has transformed them. They reach 30 centimeters in length, looking like pale, monstrous cockroaches patrolling the seafloor for debris falling from the ocean's upper layers. Then, a ghostly form floats in front of the window. It's the Mariana snailfish, Pseudoliparus swiri. It's the apex predator in this extreme ecosystem. Its body is gelatinous, almost transparent, scaleless. Its thin skin allows pressure to equalize both inside and outside its body, preventing it from being crushed. It doesn't look like a fish. It looks like a phantom, a mere sketch of life drawn for a place where life shouldn't have a foothold. Our vehicle's cameras record everything. The discovery of bacterial communities feeding on sulfur and methane emanating from hydrothermal vents. Life that doesn't rely on the sun, but on chemical energy from Earth's own interior. It's a complete, complex, and utterly alien ecosystem thriving in the planet's most inhospitable place. The sonar echoes, mapping the terrain, but sometimes the echo returns differently. Science can explain the snailfish, it can explain the amphipods, but there are things in the Mariana Trench that defy our explanations. In 2016, NOAA researchers lowered a hydrophone to the bottom of the Challenger Deep to record the ambient sound of what was thought to be the quietest place on Earth. What they heard wasn't silence. They recorded strange groans, metallic sounds, and a deep, complex noise that lasted for several seconds. The sound covered frequencies from audible to ultrasonic, ruling out most known whales and geological sources. To this day, the origin of this sound is classified as unknown. The anomalies aren't just sonic. Probes and unmanned vehicles have registered shadows on sonar, immense shapes, dozens of meters across, moving in ways that don't correspond to any known creature or geological phenomenon. These forms appear for an instant and then vanish, leaving behind only unexplained data and unsettling questions. What could create a 50-meter shadow on sonar 11 kilometers deep? And then there's the mystery of the life found itself. Why do some of these abyssal creatures possess eyes, even if vestigial, in a place where there has not been a single particle of light for billions of years? Are they evolutionary remnants, or do they indicate that their ancestors, or perhaps they themselves, did not always live in total darkness? The truth is, every dive into the Mariana Trench brings more questions than answers. We know life exists there. We've measured it, we've photographed it, but we don't fully understand how. We don't know its limits. If the snailfish is the apex predator we've encountered, does that mean it's the top of the food chain, or just the top of what we've managed to see? We've explored less than 5% of the global ocean, and of the Hadal Zone, that percentage is even more minuscule. We know the surface of the Moon and Mars in more detail than the bottom of our own planet. We stand on the surface, looking down into an abyss that covers most of our world, and we can barely begin to imagine what it contains.
every new expedition reveals creatures that seem straight out of science fiction, proving that life's limits are far broader than we once thought. But it also reveals how little we truly know. The Mariana Trench isn't just a geographical place, it's a frontier, Earth's last unexplored frontier.
And what's most unsettling is that the Challenger Deep is just one point in a trench 2,500 kilometers long. What hides in the hundreds of kilometers of darkness that have never been illuminated by a single human light? What thrives in the pressure and cold far from our eyes and our instruments? But the mysteries of the deep sea are not limited to creatures. Sometimes they are sounds. In our next dive, we'll investigate the BLOOP, the underwater sound no one has been able to explain.